Operations on Object Storage Container. To create an S3 container, navigate to the Object Storage and Container in the Horizon user interface. Click on the Create Container. Provide name of your container. Storage policy is set to default and container access to not public. As we can see, container has been successfully created. Next, go into your newly created container. Click Folder button and create a folder to upload files. Next, we can upload some files via the button near Folder. Click Browse and attach your file. Next, click Upload. As we can see, our file is currently available in our container. You can also download your file from the container by clicking the Download button. Demonstrate the capability of making the object storage container publicly accessible. Let's select our container and check the box for public access. Status changed, now we have a link. Next, click on the link. What we can see is that files uploaded previously are now listed and accessible by anyone with the link. Let's use this fact to download some data to our virtual machine. Copy link and switch to the terminal. Now we can download the data. We will use two commands for this, curl and wget. We execute the curl command with the link we copied earlier, and specify what output we want the file to have. As we can see, the file has been downloaded. Let us now display the contents of the file using the cat command. We will now use the wget command to download the file. We display the contents of the file to ourselves as before. In this case, we will configure our virtual machine to access our private object storage via S3CMD tool. It will be API-based access. S3CMD is a command line tool and client for uploading, retrieving and managing data, and it's ideal for batch scripts and automated backup to S3 storage. Let's now download this tool to our virtual machine and configure access to our storage. Switch to the Horizon dashboard and download our C file. Switch to the terminal and source your previously downloaded RC file. Execute a server list command to check for correct authorization. As we can see, we are correctly authorized. Let's now generate EC2 credentials. Those will be used for configuring S3CMD. Keys have been successfully generated, both access and secret. Installing S3CMD. In my case, the tool is already installed. Next, we configure access to our bucket. We enter the previously generated access key and secret key. Region, we leave the default value. We enter the corresponding endpoint and DNS style. We leave the rest of the configuration with the default values as they are proposed. Click Y on the keyboard and enter. We then save the configuration by pressing Y on the keyboard and clicking enter. Let's use the S3CMD-ls command to display our available containers. As we can see, our container is displayed. Let's display the contents of our container. We can see that the file and catalog that were created earlier are in the container. We delete the file using S3CMD-del. If we want to display the contents of the directory, we specify the full path in the ls command. Now we upload the file to our container. The file has been uploaded correctly. We can display it for ourselves to make sure we see the file in the container. Now we upload the test.txt file into our container. As we can see, it has been added correctly. We can also view its contents for ourselves. Show capabilities of Islet services, creating and accessing Kubernetes environment. Islet users can create clusters, thanks to a dedicated OpenStack component called Magnum. Magnum is an OpenStack project that offers container orchestration engines for deploying and managing containers. During the presentation, we will first show the process of creating a new Kubernetes cluster, how to do it from the Horizon UI and how to connect to such a cluster using the Kubernetes command line tool called kubectl. Once we have connected to the cluster, we will show some basic Kubernetes operations such as creating a claim to a persistent volume, creating a new pod, accessing a pod and creating a new persistent volume. Navigate to the Container Infra and Clusters tab. Click Create Cluster. In the Details section we fill in the name of our new cluster. Select Existing Cluster Template. In simple words, cluster templates contain saved configurations and labels that you can use to create clusters, such as flavors for nodes, auto-scaling options, etc. Leave Availability Zone Nova as default, and select your key pair. Click Next. In section size, select the number of master nodes, the respective flavor, the number of worker nodes with flavor, select auto-scaling worker nodes and click Next. In the Network section, select the Load Balancer option for the master nodes, select the flavor for the load balancer, as an ingress controller we will select Nginx. And click Next. Enable Automatically Repair Unhealthy Nodes and click Next. Labels is a general method to specify supplemental parameters that are specific to certain COE or associated with certain options. Their format is key equals value pair and their meaning is interpreted by the drivers that uses them. Click Submit. As we can see in the top right corner, the cluster has been created successfully, but its status is still in progress, so we wait patiently until the process is finished. In the meantime, as the cluster is being created, we can install the Magnum client to display the clusters using the CLI. Go to the terminal. Installing Magnum client. In my environment I already have the client installed, therefore during the installation the information displayed on your screen will be different. Next we download kubectl tools. Kubectl uses kubeconfig files to find the information it needs to choose a cluster and communicate with the API server of a cluster. Change file permission. Move file kubectl. Check version of kubectl client. As we can see, our cluster has been created. Status of this cluster is Create Completed. Below we can see clusters config node addresses, API address, cluster template, etc. Switch to the terminal. Let's source our RC file. Provide password. Make sure that the authentication has been successful. Execute command OpenStack server list. Execute the command OpenStack co-cluster list. This displays the list of clusters in your project. Copy ID cluster. Now execute command for downloading cluster config files to our local directory. As we see, now it displays command for setting environment variable, so I will simply copy and paste it into my terminal. Let's try the command without exporting kubeconfig. As we can see, there are errors in the display of nodes. Copy all path, export kubeconfig, paste and click enter. Command kubectl get nodes now correctly displays all our nodes. Connection established, now we can work on our cluster. Firstly, let's list available storage classes. Storage classes in Kubernetes enable the deployment and consumption of persistent volume storage resources. Storage classes are needed in order to create a new PVC, persistent volume claim. PVCs are requests for storage resources in the cluster. Such request can be defined as YAML file. I've prepared earlier such persistent volume claim as dynamic storage.yaml file. I will show you how such file looks like. Now let's apply changes via apply command, kubectl apply f dynamic storage.yaml. Persistent volume claim is created. We can also list persistent volume claims via get pvc command, kubectl get pvc. Now we will create a new pod, and as previously, it will be defined as code in the YAML.file. In the Kubernetes environment, Pods are the smallest deployable units of computing that we can create and manage. Pod is a group of one or more containers, with shared storage and network resources. Persistent volumes are consumed by pods using persistent volume claims. Our pod is stored as check.yaml. I will now show this code. Let's apply changes once again via apply command, kubectl apply fcheck.yaml. As we can see, a new pod has been created. Now we will use exec command to get a shell into our pod. We are now in the pod. From this level we can, for example, manage containers which are located here. We will now create a new file via touch command. File is created. Now we can exit the shell. Let's now delete and recreate the pod. Now we will use exec command to get a shell into our pod. Execute command to display file. As we can see, the previously created file is still accessible, because it's stored on the persistent volume. Creating new project and adding users. Navigate to the Identity Projects. Click Create Project. Provide the name of the new project. You can also add members to the project. Click Create Project. As we can see, new project has been created. Let's create new user. Click Users. Click Create Users and provide username and password. You can enter an email, but it is not required. On this step you can set your primary new project, set a role and click Create User. Switch to Project tab, and select Manage Members in your new project. In this step, you can manage the permissions for your project by assigning the user the appropriate roles. Let's log out from Horizon. Now try to log into our newly created user. Firstly, provide domain name. Secondly, username and password and click Sign In. As you can see, we have access to the newly created project and can create and manage our virtual machines in it. How to add, modify, or delete DNS records. DNS zones is fixed in the tenant. To add a new DNS zone to your project, you need to submit a request to our support team. Go to Desk Portal, navigate to Support tab and click on Contact Us button. You will see a form that should be filled out with your information. Follow the instructions on the screen and select the options accordingly. Fill out the description field including the following details. Project ID, this can be found in the Horizon panel under Identity Projects tab. Zone name, the name of the DNS zone you wish to add. Owner email address, the email address associated with the zone owner. TTL, time to live, specify the TTL value, which defaults to 3600 seconds unless stated otherwise. Type of zone, optional, indicate whether the zone is primary or secondary. Once we receive this information, our support team will share the requested DNS zone to your project. As you can see, DNS zone has been shared. You can now create any record in your DNS zone. For the example, I selected the A record. Click Submit. Select our shared zone. Here we have overview details about zone and your record sets. As we can see, our new record set has been created. You can also delete your record sets by clicking Delete button. It is not possible to delete the DNS zone from the user level. If you want to delete the DNS zone, you also have to submit a request to our support. Short description of IPv6 protocol. DNS infrastructure supports external networks with IPv4 and IPv6 dual stack support in line with OpenStack Yoga release. Users can create subnets with IPv6 addressing, connect VMs and routers to them. Every VM that requires an IPv6 address should also be connected to an IPv4 interface. The IPv4 interface can be associated with the local subnet, but it is necessary for connecting to the metadata service. The user can create a network using a private subnet pool or obtain public IPv6 addresses using the IPv6 subnet pool available in the project. Creation of IPv6 network with router. We will create an IPv6 network together with the router using the CLI. Firstly, source your RC file and provide password. Make sure that you are able to manage in your project, exec command, OpenStack server list. Initiate the creation of a network by executing the following command. Set the subnet configuration to determine the address allocation for your network. Enable routing capabilities within your network infrastructure to foster communication between subnets. Configure the router to connect to an external network, granting access beyond your local environment. Integrate the newly created subnet with the router to ensure seamless device communication across the network. Let's switch to the Horizon dashboard. Navigate to the network routers and click Routers. Now we can see that our new IPv6 router has been created successfully. Click Network, and we can see IPv6 network has also been created. Check the Subnets tab. Accessing with DNS to go, client installation, configuration and usage on desktop images. For the purposes of this video, I have already created a virtual machine called VM Desktop. The virtual machine must have a floating IP attached. We need to have the security group, allow ping SSH/RDP added to our machine. The key must also be added. And it's important to choose an image with the name desktop, as these images contain the X2Go server installed. Go to Images, and as you can see we have 4 desktop images available with the X2Go server already installed. Go to the Instances, and copy floating IP from our virtual machine. Open the terminal. Now, install X2Go client. In my case the client is already installed. After installing, open your extension to Go client. Configure your new session. Provide name of the session. Paste your floating IP address in the host section. Default login is EO user. SSH port is good, 22. Select your private key from the virtual machine. Set the session type to XFCE and click OK. Double-click on the newly created session. Wait a moment, and as we can see the connection to our virtual machine was successful.